Dear students, welcome to my educational channel Nayan Academy. Today I will discuss about the thermodynamics in the physical chemistry. Okay. HS first year. Thermodynamics. What is thermodynamics? Thermodynamics, it is the branch of chemistry that deals the change of heat in a chemical or physical processes. Okay. Definition here. The two terms involved here, one is system and the surrounding. A system is a specified portion where the observation takes place, and the remaining part other in the universe other than the system is called surroundings. System plus surrounding is the universe. The boundary wall between the system and the surrounding is called the boundary. Okay. The types of system: open system, closed system, isolated system. The definition here: in open system there is exchange of matter as well as energy takes place. In closed system only energy can be exchanged. Okay. And in isolated system there is no exchange of energy and matter between matter takes place between system and the surroundings. Okay. State function, path function. State function, which depends on the states of the matter, that is the initial and final states of the reaction, and the path function, which depends on the path by which change takes place. Okay. We have to work done to brought about a reaction. Then if we work done on the system, W is positive, and when the work done is by the system, W is negative. When heat is absorbed, Q is positive. When heat is released, Q is negative. A definition here given. Some lines are important, very important for board as well as entrance exam. The first law of thermodynamics. What is first law? The law states that the energy can neither be created nor be destroyed, although it can be transferred from one form to another form. This is the law of thermodynamics. First law of thermodynamics, and it is also known as law of conservation of energy. The mathematical form: delta equals to Q plus W, and delta equals to Q minus W. Q plus or minus, plus on the system, work done on the system, and W minus, work done by the system. This is the formula. Some formulas is the isothermal irreversible process, work done for isothermal reversible change, work done for adiabatic processes, that is the W is constant. Okay. The equation of enthalpy for a reaction: delta H equals to delta U plus P del V. For infinitesimally small, very small change, del can be used. Okay. Where del H is the negative for exothermic process and positive for endothermic process. Extensive and intensive properties. Extensive properties depends on the quantity or size of the matter present in the system. Mass. Extensive properties depend on the size or quantity of matter present in the system. Mass, volume, internal energy, enthalpy, etc. are the example of extensive properties. Okay. Intensive properties that do not depend on the size or matter of the size or quantity of matter present in the system. Heat capacity. Heat capacity is the amount of heat required to raise the temperature from lower to higher divided by the temperature difference is called the heat capacity. It is denoted by C. C equals to Q by T2 minus T1 or Q by del T. Okay. Some lines are here. If the amount of substance is 1 gram, then the heat capacity is called specific heat capacity. If the amount of substance is 1 mole, then it is called molar heat capacity. Okay. The heat capacity at constant volume is denoted by Cv. Heat capacity at constant pressure is denoted by Cp. this is the relation between Cp and Cv. Cp minus Cv equals to R, where R is the universal constant. Okay, this is the derivation of delta U. We know delta U equals Cv, also known as, we also know that Cv equals to del U by del T and Cp del H by del T. Okay, here equation, putting the equation del H equals to U plus Pv, from kinetic ideal gas equation, Pv equals to RT for 1 mole of gas, delta H equals to U plus RT. Okay, for independent assembly small change del can be used. Okay, delta H equals to U plus R del T, delta H minus delta U equals to R del T. Putting equation given as equation 1, this equation given as 1. Now putting the values of delta U and delta H, we get Cp del T minus Cv del T equals to R delta T, and Cp minus Cv equals to proof R equals to proved. Cp minus Cv equals to R. Okay, thank you.